Makia Minich has been working in HPC since 2000, with a history at Lawrence Livermore National Laboratory, Oak Ridge National Laboratory, and Sun Microsystems. He's worked in many aspects of HPC. Currently, Makia is principal engineer at Xyratex, responsible for the architecture of the cluster store software stack.
All right, so I'm going to start with what my talk is not. Unlike most other people, the title of this talk is a little bit not truthful, because I didn't really want to talk about Lustre at all. Coming to a Lustre conference in front of a bunch of people, I just knew if I started talking about Lustre, Oleg or Shadow would just start peppering me with questions, and I don't want that. So I'm going to lay off of the Lustre stuff. I'm going to focus more on management software. I'm also going to try to limit my time of saying cluster store, because I'm not a sales droid. We have a table outside. You can talk to some people. You can find me later, and we can talk about that there. But I'm pretty sure we want to talk about non-vendor specific things, so we'll stick to that. What will I talk about then? The overall, what do we do with clusters? What are the important bits of them? What tools are available? This extends beyond Lustre. These are also, you can attribute this to compute systems for just what you want to do at home. If you're like me, which I suspect a lot of people are that in this room, that have far too many systems in your house and you just don't know what to do with them all. There are tools that we have that are available that we may or may not know. And the other part of this is, in my history, especially with the Lustre people, is that I've learned that Lustre developers see the system as installed, and I'm going to put Lustre on it. And after that, it's all tech support questions and how do I do this, and why isn't this RPM installed over here, or this app package over here, and all this. So, hey, maybe you can stop calling me as much and you can do it yourself if I tell you some tools. All right. So what are we managing? I went out, all right, there's the marketing ploy there of Synexion in the top corner at NCSA. But the rest of them are, if you do a search for supercomputer, cluster, or whatever you want to look up, random things come up. And it ranges, you know, you've got just a bunch of boxes sitting on a couple of shelves. You've got these guys, I don't even know what they're doing. They're just staring at it. They were probably just posing. We did that a lot at Livermore. You know, and clusters, we call them a bunch of different names. Clouds, clusters, what if it's a file system, just a bunch of group of nodes, or what if you're also dealing with multiple data centers? In the end, it's a bunch of nodes sitting together. We're trying to make them talk to each other, and we're trying to make our lives easier so that the application people at the end can go to sleep at some point, and hopefully we do too. So what do I find important? Well, first off, I put scalability because it's a buzzword, and if I didn't put that there, then some managers would come after me and go, why isn't this scalable and all this? So I had to put that there. It seems to be important. Mostly, I take scalability as in tools that I can use across all the systems, tie them together, and hopefully as big of a system as possible. There's I think there was a time that somebody said infinitely scalable. I've always wanted to work that in, so I just did it. And that is always a fun joke. So the pieces that I care about, though, installation, monitoring, how do we do multi-node administration, how do we do multi-node configuration. I'll give a few tools that I've used. They are by far not the end-all, be-all tools. We all have tools we like. Your tools might be better than my tools. Great. It'll be fun to figure out how to do things better. So first you got to look at the basic system. A lot of people forget about the Linux system itself. There's a lot of good tools that are already there. NTP, SSH. Things that a lot of people forget about, setting up SSH keys. Getting from node to node is important. Doing it fast, doing it easily. NTP, it sure would be nice if I logged into everything and it all said it was the same time and then it didn't break whatever else. The number of times that I've seen people set up a system and they forget to set up NTP is amazing. So, you know, don't forget about these things. when you're starting to set up bigger overall environments, DHCP, Pixie, ways to bring up the nodes easily, configure them easily. Cron and AT, awesome. It's nice to schedule some stuff so, at 2 in the morning when I don't want to be awake, but I likely am, I can at least forget what I was supposed to do at that point, and I can let the system take care of it for me. There was a question, syslog, especially like syslog NG, however many other versions of syslog that you want to talk about, having a central logging system, have everything just feed to the same place. That way you aren't constantly going out to all of these nodes and having to see what is that node up to and all that. Also mentioned previously Crash, VM Core. These are also local tools that are available. I didn't write them down because I got tired of writing slides. So administering the system, more of the installation side. There's a lot of approaches for disk full, disk less. We can go through different reasons for why do I want to go one way or the other. Some tools that people use for disk full installation. You'll notice some of these tools are mine because I like to advertise my own projects. Disk full installation, Kickstart. I don't know why we're still using Kickstart, but it's all over the place. I even found an Ubuntu version of Kickstart, which was weird. Yaki, that's been available for a long time. It's something that I co-authored at Lawrence Livermore National Laboratory. Seems to be a good tool. Big difference between the two tools and then, System Imager, all these other ones that are out there, kind of old school tools, is do you want to do an RPM-based install or do you want to do an image-based install? I favor image-based installs. They're easily repeatable. Can do some configuration at the end. A lot of people like to do package-based installs because the tool is there and it's built into Red Hat. I think that's the best I can come up with on that. So diskless. That's my personal favorite. I like ripping disks out of systems, which I probably shouldn't say as a storage company. I like to rip root file systems out of nodes. Let's call it that. A couple of tools that are out there. OneSys, Jedi, another tool that I created, and just going that route allows you to take a single shared root file system, use all the tools to network boot them, bring them up, and give you one place to kind of sit and take care of your system or multiple systems and add packages, change configuration files, all of that in one place without having to log into all the nodes and wonder what they're doing. Very important, configuration management. Kind of, a lot of places, we all have a tendency to, I just set up my desktop, and I just set up this, and oh crap, I forgot to set up this system, and now I've got another system. By that time, you're up to 10 systems, and you're doing it by hand here, and I had to put this in, let's see, hosts over here. If you just, at that first system, set up something like Puppet, Chef, number of other configuration management systems, you set up those configuration files there and let them propagate, and then you kind of stand back, and it looks like magic, and most of the time it is. Don't dig into Chef and Puppet because it will be more magic than you want it to be, but they work. So looking more at tools for execution, parallel shells are your friend. Logging into random systems and running the same command over and over again seems dumb. And so being able to do it from a single command line, tools like pdish and dish, allowing you to pick up groups of nodes rather than you can choose all the nodes, partial lists of nodes, and just helps your overall day not be filled with a lot of copy paste and did I do that node over here and what I forgot that one, and some manager is going to yell at me because I took half this cluster down because I forgot how to log into it. So pdish, great. Also looking at execution frameworks. There's cluster shell, Slurm, number of other resource managers. A lot of people are using them for, well, what they were built for, of job launches, using it for computation and everything else. But they also work really well at just launching sysadmin type jobs on your nodes. You already have it up and running. It's a scheduler. It's kind of like cron and everything else. I can set it up at a specific time. I can give it variables. I can tell it what nodes, what type of nodes, what to look for. And I can have activities happen on my system at interestingly scheduled event times. Kind of a cool way. I actually have used this at home. That's probably why people get onto my systems and don't know what the heck is going on. So monitoring, very important. A lot of systems out there. I will point out neither of these pictures come from Cluster Store. I didn't want to use that. So these are just kind of your normal. I did a Google image search for Ganglia and Nagios, and these were the first two pictures that popped up. Some different monitoring tools that are out there. Nagios, Isinga, they do more of a polling. At some point in scalability, if we want to go back to scalability, you have to choose, is polling or is multicast slash, yeah, whatever. So which option do you want to go in that? LMT for Lustre, other tools. Just allow you to get that view of what the system is doing so that I don't have to keep looking at logs and keep looking at these. Visual pictures are always nice, and they're very helpful at my house when a graph kind of spikes. I realize that my torrent is probably taking too much of my network connection, and I should look for a different torrent. So, kind of looking more into the advanced tools. Failover. John kind of talked quite a bit about that. Different options in the failover packages that are out there. Of course, Sync, Heartbeat, Pacemaker, all effectively do the same thing. Different ways to configure all of these pieces. We do a lot of a two-node failover. Are you going to do cluster failover? Too many options in this space, but there are a lot of tools and help out there on the web. IPMI, heavy use of IPMI. It's awesome to be able to turn on and off a node without having to walk wherever that computer is and hit a button. A lot of tools that can use IPMI, so just the standard IPMI tool stack and some wrappers on top of them. I am a happy user of Conman and Powerman to give me console and power access. There are likely better ones out there as well, but that's what I use, and I will likely probably keep doing that. So I'm going to go into a minor rant for a bit. A lot of us have firmware on every part of the system, BIOS, enclosures, HCAs, everywhere. And the number of tools that are out there to write firmware to all of these pieces, who knows which OS half of them are on. Some of them are DOS, some of them are Linux, some of them, who knows, maybe they decided to write their own thing. It's difficult. You have to know which tool to write to this piece to do that, and it's ugly. Some of them, when I have to take an entire cluster, and I've done this probably about 4 or 5 times in my life, and network boot DOS on 1,000 nodes just to flash the BIOS, it makes me feel dirty. And you know, there's that little part of it that's just like, oh, this was great. Look at this cool thing that I did. But then at the end of the day, you went, well, I just booted DOS on 1,000 nodes, and thank God it didn't turn into a badness. We'll go with that word. So, continuing the rant, no more DOS, really? Why are we still using a lot of these DOS tools? It'd be nice to see a lot more command line tools. It'd be nice to see something like Core Boot being taken in more into some of the hardware so that we actually have a lot more controllable of a BIOS on some systems. Also, we need to minimize reboots. There are a lot of different firmwares that require certain parts to go down or to reboot underneath you. You know, in an enclosure, there are too many moving parts, and who knows what's going on with some of them. So, being able to schedule that or at least minimize it is a huge win, and doing it out of band as much as possible. So, where do we go? So as I was writing these slides, it just so happened that on Inside HPC, this video popped up, and it was about and what's missing from HPC. And I watched it, and I don't usually watch those because sometimes they're a little slow to watch. But the main thing that I got from this was that we're missing new blood in this world. We're not necessarily teaching a lot of this, and we're going through all of these, and we're relying on the people that already exist. And what we need to do is go out, start finding new people to start filling in this world. Things like these cluster challenges at SC, it'd be awesome to see more of those. To start getting into the universities, getting more people, getting hands onto the clusters, and seeing what tools they come up with, because it's awesome to get new eyes on it and see what they can do. I also mentioned a couple of cluster suites. Suites are nice. They manage all the tools. They bring in all these ideas, and there's different options out there for it. So there are some options. There are way more than that. I got tired of the Google search for it, and I wrote those down. And that's it.
Questions for Makia?
Yay. Oh.
Why didn't you include security? It's just a big Linux cluster, and you got thousands of nodes out there that could be accessed and hacked.
Because I had 20 minutes that kept shrinking. I mean, there are so many different aspects of these systems. I just picked kind of the random top thing. This really came from me taking a system at home. As I was told, hey, you should put this slide set together, I took some nodes at home, I put them together, and I went, well, this is the first thing I want to do. This is the second thing. Security didn't come up because I was pretty sure I wasn't going to hack myself that day. Who knows about the next day?
For diskless environments, you talked about OneSIS and Jedi. Do you have a preferred tool?
Well, I prefer Jedi because I wrote it. OneSys is a fantastic tool, though. There are a number of other tools that are also out there. They're pretty easy to find. OneSys does a fantastic job of bringing in a lot of other, like simplifying the overall management of the diskless cluster. Jedi is helpful in creating images and kind of setting up the environment.
Okay.
What about for monitoring large InfiniBand networks? What tools are available for that?
Mostly the internal tools for InfiniBand. It's been something that I know has been talked about quite a lot, or been wanted for quite a lot of time. I'm still falling short on trying to find those at the moment, and I'd love to have some options. So if anybody wants to yell at me and tell me what to use for that, and wherever Dillo is, hopefully he has the bright idea that I need to follow.
The one thing like that, the paid tool, UFM for Mellanox is more of a monitoring tool that requires a license.
Yeah, UFM from Mellanox, that's what he was mentioning. Licenses scare me at this kind of stuff, so I was hoping for something that I could just put onto my system. I've strayed away from that at the moment, but UFM is out there.
Okay. Makia Minich, thank you.